Good morning all. Myself Mishaha MK, Assistant Professor Computer Science and Engineering, Vedavyasa Institute of Technology. Today I am discussing about hand gesture recognition using CNN, Convolutional Neural Network. Hand gesture recognition is a rapidly evolving field in computer vision and human-computer interaction. It also plays a significant role in human-computer interaction, especially in contexts where direct manipulation or touch interfaces are involved. Then next let's discuss about importance of hand gestures. First is communication. Hand gestures are a fundamental part of human communication, often used to convey meaning, emphasis, and emotions alongside spoken language. Then in non-verbal expression, they allow us to express ourselves non-verbally, supplementing or even replacing verbal communication in certain situations. Then in cultural significance, different cultures have developed distinct hand gestures vocabularies reflecting their customs and values. Understanding these gestures is key to cross-cultural communication. Then phenomenon is accessibility. This is the main one. For individuals with speech or hearing impairments, hand gestures can serve as a primary mode of interaction and self-expression. There are different types of hand gestures we are using. First one is tactile gestures. That means pointing or indicating direction using the hand, finger or entire arm. The next one is iconic gestures, visually representing the shape, size or movement of an object or concept. Then next one is emblematic gestures. This is culturally specific hand signals that convey a particular meaning like thumbs up or peace sign. The next one is hand gesture data collection. Data collection has three steps. First one is data gathering. In this, collective diverse data set of hand gestures from representative samples of users, capture images and videos from different perspective and lighting conditions. The next one is annotation. In this, carefully label each data sample with the corresponding hand gestures and any contextual information. Ensure accurate and consistent annotation to enable effective training and testing. Then next step is pre-processing. This is the final step. In this step, pre-process the raw data by normalizing, resizing and cleaning the images and videos. This prepare the data for feature extraction and model training. Then let's discuss about feature extraction techniques. There is mainly two types of extraction: manual feature extraction and automatic feature extraction. In manual feature extraction, extracting distinctive features from hand gestures is a crucial step in recognition. This involves analyzing the hand shape, orientation, motion to identify unique patterns and characteristics. The common features extraction techniques include edge detection, contour analysis, and motion tracking is included in automatic feature extraction. This method helps to capture the essential information needed for accurate and hand gesture classification. Then we are going to discuss about hand gesture classification algorithm. In this, we are using CNN, convolutional neural network. Convolutional neural networks are a class of deep neural networks that are particularly effective at processing and analyzing visual data like images. They consist of several layers, each designed to extract relevant features from the input data. The first layer is input layer. This is where the input data, usually input data is an image, is fed into the network. Each image is represented as a grid of pixel values, with each pixel having its intensity or color information. The next layer is convolutional layer. In this layer is the core building block of a CNN. It consists of a set of learnable filters. This filter is also called kernels that are convolved with the input data. Each filter detects specific features in the input such as edges, textures or patterns. During training, the network learns the values of these filters that best extract features relevant to the task. Then next in this have activation function. After the convolution operation, the activation function like RLU, rectified linear unit, is typically applied element wise to the convolved feature maps. This introduces non-linearity into the network, allowing to learn more complex relationship between features. Then next is pooling layer. In pooling layers are used to reduce the spatial dimension of the feature maps while retaining the most important information. There is max pooling. For example, takes the maximum value from each local region of the feature map, effectively downsampling it. This helps in reducing computation and controlling overfitting by providing a form of translation invariance. Then next layer is fully connected layer or dense layer. After several convolutional and pooling layers, the final feature maps are patterned into one-dimensional vector and fed into one or more fully connected layers. These layers act as a classifiers using the learned features to make predictions about the input data. Each neuron in a fully connected layer is connected to every neuron in the previous layer. The final layer is output layer. The output layer produces the final predictions of the network. Depending on the task, this layer may have different configuration. For example, in a classification task, it may have one neuron per class with a softmax activation function to produce probabilities for each class. In this, we will get 5 different hand gestures. We are using hand gesture for CNN. So we will get the output as 5 different hand gestures. Thank you.